Have you ever wondered how Apple makes you feel like you absolutely need that sleek MacBook Pro just by scrolling through their website? Those buttery smooth animations, the way the laptop rotates in perfect 3D space, how every scroll feels premium. And suddenly, you're calculating if you can survive on ramen for 3 months just to be able to afford it. See, Apple doesn't just build websites, they build experiences that make an impact that eventually makes you buy that new Apple product that you don't really need. But here's the question: what if you could do it too? What if every website you create could also make your users stop mid scroll and think, holy crap, how did they just do that? What if your work didn't just wow some random visitors, but rather turned them into customers, or even landed you that next big gig or that job? Hi there, and welcome to a brand new video where I'll teach you how to create a MacBook Pro landing page clone that looks and feels exactly like the Apple's masterpiece. You'll learn to develop cinematic hero sections with scroll synchronized video backgrounds, interactive, photorealistic 3D MacBook models that users can play with, parallax masked video rendering that feels alive, scroll trigger effects giving us precise control over animations and timelines, advanced scroll storytelling that guides users through an emotional journey, a sleek bento box layout that presents content in visually balanced modular sections. All of it with optimized performance and responsive design that works flawlessly across all devices. And we're not just gonna copy Apple features here. You'll actually learn the skills behind them, including React.js for dynamic scalable UI rendering, Tailwind CSS for pixel perfect styling, Three.js to load, light up, and animate realistic 3D models, GSAP for scroll triggers, timelines, sequencing, and buttery smooth transitions. And because we're not vibe coders, but developers, we'll implement all of the best code practices and guidelines using CodeRabbit-assisted code reviews and their new CLI to make your project feel as premium as Apple's own site under the hood. To push you even further, I've prepared a complete GSAP and Three.js guide packed with pro tips, examples, and advanced project idea. You can find it within the video kit down below completely for free. And if you really want to go beyond just following along, if you want to understand the psychology behind why these animations grab attention, hold users in place, and make a product feel irresistible, and then learn how to design and build your own from scratch, I've put all of that into my GSAP Mastery course. That way, you won't be just copying Apple's animations. You'll be creating experiences that feel just as premium entirely on your own. Link is down in the description. So, I hope you're ready to stop just admiring Apple's designs and start creating them yourself. Let's get going. And since my goal is to make sure you land a job, this app is not just a regular project. It's a career asset designed to showcase everything you're capable of, making you an attractive candidate for any job. See, hosting your website on a personalized domain makes you more professional and improves your credibility. It also highlights your skill in self-hosting, scaling, and managing websites. So before we dive into the code, we need to set the foundation. I highly recommend Hostinger for hosting this app, and they're offering an amazing deal right now. So click the Hostinger link in the description and then click Start Now. When it comes to hosting this app, I'll personally go with the premium plan. It allows you to host 25 websites with the same account, has 25 gigs of SSD storage, you get a free domain for 1 year, and free SSL for HTTPS security, which builds trust with anybody visiting your site. This deal won't last forever, and because I've partnered with Hostinger, you'll get an even bigger discount. So click the link in the description, start now, and choose a plan. Here, we have to choose the period of our hosting, and with the amazing deal going on right now, I'll choose 48 months to save the most. If you already know the domain name you want to get with the hosting, you can type it out right here, or you can do that later. And most importantly, here's that additional coupon code that I promised. Just type in JavaScript Mastery, and you'll get an even bigger discount on your hosting package. You can now continue, and very soon, we'll start developing our app. Once you're in, we can continue with Hostinger's guided setup. In this case, we're creating a new app. Since we are real developers, we won't be using WordPress or the website builder, but rather we'll start with an empty website. And now here, you can choose your domain name. I know we're still early in the project, we haven't yet started building it, But you've seen the intro and you might already have an idea about how you want to name it. So just type in your domain name right here. As you can see, I'm already using Hostinger for all of my domains. Or if you're really not sure, you can use a temporary domain for now and then choose a real one later on. And that's it. Your domain will get registered. Next, you'll have to choose a server closest to where you think your users will be so your website loads fastest. Feel free to choose anything here. And that's it. The setup is now initializing. While that's happening, I want to let you know that there's a complete GitHub repo for this entire code, which is entirely free. You can click the video kit link down in the description, and there you'll be able to learn more about JS Mastery Pro, our platform for premium courses. But here, you'll also be able to find a completely free Tailwind guide, Three.js guide, Tailwind CSS crash course, and the source code for the code alongside the entire Figma design and the assets. So everything you need regarding this project will be right here, completely for free. And that's it. Our hosting has been set up, and now we are ready to dive right into the code. Before we start developing this design masterpiece, let's actually set up the environment so that later on we can just focus on coding. First things first, click the CodeRabbit link down in the description and create your free account. We'll use CodeRabbit's PR reviews and their new CLI all throughout this video, so let's make sure to set it up right away. With that in mind, let's go ahead and check out the entire demo of the application you'll build today, starting with a very simple navigation bar and an animated hero section, moving down over to taking a closer look at the product that our users will be buying. You can also change the colors and the sizes. Scrolling down, you can see this beautiful parallax video section that as you scroll, actually shows you the name of the chip that's inside of that MacBook. Then a bit more info about it. Finally, you have this section where these different screens reveal what you can do on the MacBook itself with more info. Finally, this beautiful animated section that tells you what you can do, while at the same time showing you a video of that happening. So here we have image AI, email AI, summarize, airdrop, and more. And all of that also happens when you're going back. Beautiful. And finally, a nice bento grid of all the features. That's it. Super precise, shows you everything you need to know, nothing more, nothing less. To build this app, I'll be using React, but you're completely free to choose from any of the front-end frameworks. If you want to use Next.js, or Angular, or Vue, or whatever it is, you're completely free to follow along, make small adjustments, and adapt my code to your needs. Also, make sure you've set up your code editor. I personally use JetBrains' IDEs because of their advanced auto-completion, error tracking, advanced integrated Git workflows, and overall better code intelligence. It's a full IDE after all, and with it, you can also get Junie, JetBrains' coding agent. It is super useful, and I'll show you how we can use it within this application to speed up your development workflow. That said, let's go ahead and create our application. We'll use Vite to quickly spin up our React app. So head over to Vite and click Get Started. Then if you scroll down a bit, you'll see a command for running Vite. So just copy it. Or if you're using WebStorm like I am, you can just go ahead and create a new project. Immediately choose Vite right here, and then choose a Vite template. In this case, I'll go with React. This will run the same command for me. And you can name the folder something like MacBook GSAP app. Once you're within it, you can run the command you copied over from Vite, and make sure to add the / at the end so it creates it in the current repository. I'll say remove existing files and continue. Choose a framework. In this case, we'll go with plain JavaScript, but once again, if you want to use TypeScript, you're more than welcome to, and no need to use experimental versions. We're going to install with npm and start right away. There we go. The app is running on localhost 5173, so you can open it up within your browser. And let's clean up the project a bit to prepare it for your app. Go ahead and remove the app.jsx within the source. Remove the app CSS. Remove all of the assets since you won't be needing them. Remove all the styles from index.css. And let's actually show something on the screen by creating a new app.jsx file within which you can run RAFCE. This is short for React Error Function with exports. If this didn't work for you, you must head over to Plugins and install modern React snippets, and then it'll work. If you create this app, head back over within main.jsx, you'll see that it's rendering it. And if you reload your app on the browser, you should be able to see a small piece of text that says app. Instead of that, we can maybe render an H1 and then make it say, hello, Apple MacBook Pro. And there we go. The text is there, which means that everything is working. Now we gotta install Tailwind CSS that we'll use for styling. So head over to tailwindcss.com that allows you to rapidly build modern websites without ever leaving your HTML, or in this case, JSX, and it'll give us those utility classes. So click Get Started and install it using Vite. That's the selected option. We've already done the first step, so now we just have to install Tailwind CSS by copying and pasting this command. WebStorm allows me to have 2 terminals or more. I'll name the first one app as it's already running our app, and I'll create a second one, which I'll call terminal, within which I can run additional commands all while our app is running. I'll run npm install tailwind css /vite. Once that is done, we also have to configure the Vite plugin by heading over within our Vite configuration. So copy this, head over into Vite config, and don't necessarily override this, but rather just add these 2 additional lines. Import Tailwind CSS from Vite, and then add this plugin right here to the plugins array. Perfect. Once that is done, head over within our index.css and copy this import Tailwind CSS line. Restart your application if needed by pressing Ctrl+C and then npm run dev once again. And then let's start using it. Let's copy this H1 right here that says hello world and update our current H1 that now has this not class, but rather class name of text3xl, font bold, and underline. If you now head back, you'll see that that is applied. We can do one more, maybe testing the text indigo of 700, which is a color, and you can see that it works. That means that you've successfully set up Tailwind. Now, as you can imagine, our final app will have a lot of different icons, starting from this Apple icon at the top to this magnifier glass or the cart icons right here. We got to get all of these icons and colors and themes within our application so we can later on use them. I prepared all of that for you within a free Figma design. You can see the entire app will build with all of the sections one by one, so that if you maybe want to give it a shot on your own, you can do that as well. This design, alongside the theme that it is using, which are some colors that are being repeated, even though it seems it's all dark, there are a couple of colors that we need to add to our theme. So the design and the colors are within the video kit link down in the description. Just click it and sign up for free. Once you're there, you'll be able to learn more about JS Mastery Pro. It's our pro platform for those who want to learn more. And below that, you'll be able to find all the necessary files that I'll be referencing throughout the rest of this course. One of those files will be a modified index.css. So head over into the index.css, find it within the video kit down below, and then copy and paste it right here. It'll feel like there's a lot of code right here, but most of these are just some utility classes that we'll use to make the styling of our app easier. And then as I promised, here we're setting up some fonts and setting up some of our colors. Yes, most of them are just dark, but here they are. In the video kit, you'll also be able to find the assets. These are those small icons and images that I've been telling you about. So simply click right here and then download the zip. Once you download it, simply unzip it, and then remove the current public folder, and then drag and drop the new one within the root of your application. You'll see that this one will include a couple of fonts, the 3D models we'll be using, videos, images, and icons. This way, we have everything we need to get started developing our application. Congrats on going through the setup. This one will for sure be the most boring lesson in this entire course, but immediately from the next lesson onward, we'll start developing our MacBook application. Let's start with the first piece of our UI, the NavBar. Create a new folder within the source folder and call it components. React applications are all about components, very small pieces of UI. So in this one, we'll create a new file, and I'll call it navbar.jsx, within which you can run rafce just to be able to see the text that says navbar, and then import it right within our app. Instead of the h1, we'll wrap everything into the main tag because this is the main part of our application, and there I will render the navbar. And now you can just see a piece of text that says navbar. So now let's head over into this component and let's start implementing it. First things first, I'll turn this div into an HTML5 semantic header tag, and within it, I'll create a new nav tag. Within nav, I'll render a new image that'll have a source equal to /logo.svg with an alt tag of Apple logo, and immediately we can see it at the top. Then below it, still within the nav, we'll render a new UL, an unordered list, and within here, we have to create some nav link items. So you can create an object, and then within it, a new array. Within that array, we can create different links. For example, we can create an object with a label that'll say something like store. Then you can create another object that'll be a label of, let's do Mac. Maybe another one that'll be all about not Linux. We're not doing that right here. Maybe iPhone, right? We can do another one for a label of watch or Apple Watch. Let's do another one for vision. And then finally, the last one for the AirPods. Okay, so now we have an array of a couple of objects with a label property. I'll give it some breathing room, and then I'll now map over this array by saying .map, where we get each individual link. And for each one, we want to automatically return something. When I say automatic return, I mean that you immediately put the parentheses right here and not curly braces. Because if you put curly braces, then you have to explicitly say what you want to return. But if you immediately put parentheses right here, that means that you don't have to add the return keyword explicitly because it is implied. So for each one, I want to return a link, an li, with a key equal to link.label. And within it, I'll put an anchor tag with an href of link.label. For now, these are not valid labels, but later on we can update them if you want to. And then the text will say link.label. If you want to, since we are repeating the word label too much, you can destructure the label from the link, and that way you don't have to repeat the word link 3 times. That'll look something like this. If you save it now, you won't be able to see anything just yet, but if you expand the screen just a tiny bit, you'll be able to see that on desktop and tablet devices, the navbar is right here. And below this UL, I will add a div with a class name equal to flex-center and a gap of 3, within which I will render a button, within which there's going to be an image with a source equal to /search.svg with an alt of search, and I will duplicate this button and image one more time below. This time it'll say cart.svg with an alt of cart. So now you can see in desktop, it all aligns perfectly in Apple style, Apple logo on the left, the links in the middle, and then a few icons on the right. Now, if I collapse this, you can see that on mobile, the additional links disappear, and we only have the Apple and 2 additional icons on the right. Now, to tidy up this code a bit further, we don't have to keep this data right here. I would consider this some data. That is maybe logic or info, definitely not the presentation of our JSX components. So typically, it's better not to keep it right here. For these types of data pieces, you can create a new file. So right within the source folder, I'll create another folder called constants, and I'll create a new file called index.js within the constants folder. When you name a file index, that means that you can access it just by saying constants without having to necessarily say index.js or some other name.js. Constants index is just constants. And then here, you can move this array, which for example, we will call nav links. So now if you head over to constants, you create a new const nav links and you paste this array. It's better to keep it here. You can immediately export it and then you can go ahead and import it right here. Nav links coming from constants index.js, or as I said, you can just say constants. And now we have a very clean navigation bar. Perfect. That was pretty simple, right? So now that we've implemented our first UI component, no matter how simple it is, I want to teach you how to immediately start utilizing all the best practices within your development process. One thing is to not commit to Git after your entire project is done. You want to create a new GitHub repo right from the start. So head over to github.com/new, and right here, you can choose an owner and enter a repository name. In this case, I'll call it GSAP MacBook Landing. You can give it a description if you want to, and you can leave it public and click Create Repo. Once you do it, right here, you'll get the instructions needed to connect this local repo to the remote one. So let's open up our terminal, say git init, git add dot, git commit -m, initial commit, git branch -m, main, git remote add origin, git push u origin main. With just these couple of commands, you will have pushed the current code and the assets over to your GitHub repo. So if you reload in a couple of seconds, you'll be able to see all your code pushed right here to GitHub. And that is important for a couple of reasons. First of all, other developers and potential employers will be able to track your commit history to see whether you have actually built this project or you just copy and pasted it from a tutorial. If you've been building it yourself, then all the commits will show up nicely. You can also tidy up the description, enter the URL, and some topics. This will make the repo cleaner, and at the same time, as you're pushing new code to your repos, your contributions graph will shine green. So from here on, we'll push over to GitHub for almost every section in this course. And then you'll be able to go to my repo, and if you're not sure how something was implemented, you can check that specific commit and see exactly what happened. That'll make it easier for you to follow this tutorial as well. Now, on top of setting up GitHub for every single new project that I do, another tool that became a must-have for me is CodeRabbit. It allows me to keep my code clean and catch some mistakes that I miss. So if you haven't already, click the link in the description and create a free account. In this course specifically, I want to focus on their newest product called CLI Reviews. Instead of vibe coding, it allows you to vibe check your code with smart reviews. Go ahead and copy this CLI command. And an important note is that CodeRabbit CLI is for now supported in macOS and Linux. Windows is coming soon. So if you're in Windows, depending on when you're watching this, you might be able to check out CodeRabbit CLI, but if not, you can still create an account and utilize the pull request reviews feature. And depending on which IDE you're using, you can also check out the AI code reviews right within your IDE. But now for my macOS and Linux users, let's quickly go through the CodeRabbit CLI setup. Back within the editor, I'll paste this curl command, which will download the CodeRabbit CLI. It says installation complete, and you can now restart your shell or run this command right here, which I will do. Once you do that, you can run CodeRabbit --help to see a bit more info about what it can do, or you can just CodeRabbit. This will automatically authenticate you. So I'll go ahead and authenticate using GitHub, and you'll get this token. So simply copy the token and paste it within your terminal. There we go. CodeRabbit is running. Right now, there are no new changes. That's because our NavBar was super simple, and I went ahead and committed it before running CodeRabbit. So let's go ahead and implement the hero section, and then we'll be able to see what this CodeRabbit has to say about our code. Now that the navbar is done, let's focus on our wonderful hero section that has this animated MacBook opening to us and kind of hinting that there's a lot inside. We can get started by creating a new component and call it hero.jsx. Run rafce right within it to quickly spin up that component, and then use it right here below the navbar within our app.jsx. This one will be called hero. So now if you head back over to our app, you won't be able to see the hero yet because it's being hidden by the navbar. So instead of a div, let's turn it into a section with an ID of hero so that we can scroll to it if needed. Within it, render a div, and then within that div, render a new H1 that says MacBook Pro. That's your big title. Then below that H1, render an image with a source of /title.png and give it an alt of MacBook title. There we go. Now, right below this div, render a video, set its source to /videos /hero.mp4, and then set it to autoplay, which will automatically open it up on reload, make it muted, make it play in line, so you don't see the additional settings like the volume, forward, backward buttons, and so on. And now if you reload, it'll just nicely autoplay and open up. Even though it might seem like this is some crazy animation, what it actually is just a very optimized video animation that just opens up and works. We can also make it load a bit faster or slower and modify some other video properties by attaching a ref to it. This is something we'll often do. Whenever you want to have more control over a specific video, you attach it to a ref. So video ref is equal to a use ref hook coming from React, and then you simply attach it to a video by saying ref is equal to video ref. On its own, this won't change anything, but it allows you to do more stuff with it. For example, you can open up a new use effect, and when this component loads, you can then check if video ref has been attached to any element. If that is the case, set the video ref.current.playback rate to 2. And now if you save it, you'll see that it'll open up 2 times as fast. Check it out if I comment this out. Now it's much slower. It is completely up to you what you want to do with this video and the other videos as well. Sometimes it is personal preference, but the goal of the websites is not to overwhelm them with animations. There should be some micro animations, but they should be happening pretty fast, not to make your website feel like it's slow. And then below this video, we can render a button. This button will simply say the word buy as a primary CTA, and then below it, a p tag where we can say from $1599 or $133 per month for 12 months. Something like this. There we go. Nice and Apple-like. And of course, if you expand it on full screen, it'll look so much better because this is a horizontal animation, which means that it takes more horizontal space. Beautiful. But now, let's open up our terminal. I'll head over to CodeRabbit, stop it from running, and then run the CodeRabbit command one more time. Now, it notices that there are 2 files changed with 27 insertions. You can now hit enter to hop into the review directly within our terminal. So press enter, and now it says AI pretending that it knows better than you, and it's loading the existential dread about your code. Okay, that's nice. At least it's being honest. Preparing passive-aggressive comments. I love that one. I love all of these loading messages, actually. And there we go. Review completed, this time with no comments. Well, that's absolutely amazing for us. Sure, the hero component wasn't that long, so there wasn't much to review. But as we dive developing other absolutely more complicated components, like this 3D model viewer, I'm sure CodeRabbit will find ways to improve our code. So for now, since we're good, let's just go ahead and commit it by typing git add dot git commit -m implement hero section and git push. In this lesson, I'll teach you how to build this interactive 3D MacBook Pro viewer, where your users can change the color of the MacBook from silver to space black, switch between different sizes, as well as rotate this 3D model. This layout will be divided into 3 different pieces: a headline and some product info, then the control panel for customizations, this thing right here at the bottom, and then a canvas that'll render that 3D model. Let's start by creating a new file in the components folder, and you can call it product viewer.jsx. You can use RAFCE to quickly add a new component within it, And then you can import it right here within the app.jsx by simply saying product viewer. Now, if we head back to our current version of the application, you should be able to see a product viewer text right here. Then let's develop the UI of this experience section. Head over into the product viewer, turn it into a section that'll have an ID equal to product-viewer, and then within it, render an H2 that'll say take a closer look. Then below it, render another div with a class name equal to controls. And within it, render a p tag with a class name equal to info that'll say MacBook Pro 16-inch in silver or maybe space black. There we go. You can see it right here. Below this p tag, go ahead and create another div that we'll use to center the controls with a class name of flex center, a gap of 5, and margin top to divide it a bit from the text. Here, we can render a div with a class name of color control, and there we can render 2 self-closing divs with a class name of BG neutral 300 and another one with BG neutral 900. And here you have 2 different colors. We'll always be rendering one color at a time, so for now we can maybe make it just say MacBook Pro 16 in space black. And then below this div, we'll create another div that'll have a class name equal to size control. And here we can render a div with a p tag in between that'll say 14-inch, and we can duplicate it and below say 16-inch. So now we can choose between different colors. If you're ever wondering what a specific Tailwind class name does, you can control-click it and it'll lead you directly to that CSS directive. So you can see that, for example, this size control applies a small medium to the text, flex between the elements, BG neutral, rounded full, some padding horizontal, padding vertical, and a gap in between the elements. That actually creates this outer shell. And then to each div within it, we apply a size of 8, rounded full, cursor pointer to make them appear clickable, text black, and flex center, so we know we can choose between those 2 versions. So again, at any point you're wondering what something does, just go ahead, click on it, and you'll be able to see the full CSS for it. Finally, below all of these divs, we'll render another p tag with a class name of text-white and text-4XL that'll say render canvas, because now very soon we'll start rendering the canvas right here. Before we do that, we'll have to store a lot of different things within the state. And sure, you could use React context, or you can use Zustand. Zustand is a super simple store or global state setup for React applications. So you can install it by running npm install Zustand, as well as CLSX. We'll use this for some dynamic styling with Tailwind CSS. Once you install them, you can create a new file, or rather a new folder within the source folder, which we'll call store. And within the store, we'll create a new index.js file. Here, we have to import create from Zustand to be able to create a new store. Then we'll create that store and we'll create it as a hook. Use MacBook store. It's equal to create from Zustand, to which you pass a callback function that automatically returns an object. And here you can define some global state variables, such as a color of 2E, 2C, 2E. This is the color I picked from the design. And you can also provide a setter variable for that variable, such as setColor, which accepts a color and sets it within an object like this. Why are we doing this? Well, to be able to keep track of the information of which color of the model is currently being shown. And we have to do the same thing for the scale, such as scale of 0.08, set scale, which will take in the scale and set the scale. Finally, if we decide to reset it, we have to have a callback function that will be doing just that, which can simply call set and set the color to the default color of #2E, 2C, 2E, and it'll also set a scale to 0.08. Perfect. And now this is our store that we'll export, and we'll be able to use it all across our application. So now let's use those store values and update the color and the scale within the product viewer. Head back over to the product viewer component, and right at the top, say const, and then destructure some of the values coming from use MacBook store, just like this. And make sure to import that use MacBook store from /store. Now from it, we can get the color, the scale, the set color, and the set scale setters, so that we don't have to manage that state over here. We're managing it within a global state. So all the logic will be right here, whereas here we focus on the presentation. What you can do right now is in color control, where we have this div, you can give it an on click. That'll be equal to a callback function, where you can set color and set it to the color that is being clicked. In this case, it is hash ADB5BD. Make sure to call that as a function, because that's how we've created this setter. And then this will set the color, but we also have to keep track of that color within the class name. So I will put this into multiple lines. We have a div with not an on clock. This will be an on click. And then for this class name, we will call CLSX. This is that package that we installed that allows us to set the base style, such as BG neutral of 300, but then it also allows us to check whether color variable is set to hash ADB5BD. In that case, we'll make this button appear active by giving it an active class. So now if you head over here, if you click on it, now it gets the active class. And at the same time, the color is also selected. What does that mean? Well, that means that now we can display the color right here, even though it won't be in a human readable name, but at least we can get the variable. So if we say MacBook 16 in color, you can see this color was about to be shown. And now if you duplicate this div right here and replace it with the one below, the only difference is that this one will set it to a dark color of 2E, 2C, 2E with a BG neutral of 900. And if color is 2E, 2C, 2E, then it'll be active. So now we can see how we are modifying the value in the global state, and we're changing the presentation based off of which color had been selected. We can do absolutely the same thing for the scale. So I'll duplicate this div once more and paste it right here instead of this div. On this click, we will set the scale to 0.06, which is a bit smaller. And for CLSX, we will check if scale is triple equal to 0.06. In that case, we will apply a BG white and text black. Else, we will apply a BG transparent and text white to let it know which one had been clicked. This div won't be self-closing. It'll actually render a p tag that'll render the size. And now I will duplicate this div for this 16, change the name to 16, and change the scale to 0.08, both here and here. So now you can switch between different colors, and we can also switch between different scales, which will modify this variable. So now that means that we can use this scale variable from the state to also show it right here. Of course, it's not showing the actual numbers. We'll fix that later on. But at least we know that our modifiers are working. And now we can start getting closer to displaying this big model right here in the middle. To display something in 3D, we have to install packages that help us do just that. So run npm install. The most important one is 3, as in Three.js. Then we need a helper library called athreact-3/Dre, which makes it easier to work with Three.js within a React environment, which is composed of these UI components. And then finally athreact-3/Fiber, and then run enter. While that installs, head back over to the product viewer. And for now, we will render a canvas right here below all of these divs where we have this p tag, simply by saying canvas. This, of course, has to be imported at the top, coming from React 3 Fiber. Give it an ID equal to canvas. And if you save it, you won't be able to see anything within it. So let's add a box coming from React 3. Here it is. You can play with that box by maybe modifying the position a bit, such as setting it to -1, 1, and 0, which will move it across the space. In Three.js and in any 3D environments, we have 3 axes, X, Y, and Z. X is left and right, Y is top and bottom, and 0 is how far or how close the item is. If you increase the Z, you'll see that it'll get very close, so close in fact that maybe it'll jump off the screen. But if you make it smaller, you'll see that it'll go further away. I always recommend that you play with those values and see what each one does. We can also modify the scale a bit by setting it 10 times the scale that we have chosen from our application. So you can see now, it'll actually modify the box size depending on what you click. And check this out as well. You can also apply a material dash color to it and set it to the color coming from our state. So now it's dark, and now it's white. And this box can be a self-closing component. And it appears like it's not properly centered, is it? So we can give this canvas some camera properties, such as a position of the camera, not of the box, to 0, 2, 5. We can also give it an FOV. This stands for field of view, which I'll set to 50. I'll set the near plane to 0.1 and far to 100. Now, if you reload, you'll see that the camera angle will have changed, and you can continue playing with it until you have it perfectly centered. And the most important thing is to be able to interact with it. For that, you need something known as orbit controls. And you can also give it a property of enable zoom and set it to false, because we don't want to be able to zoom, we just want to be able to move it around. Right now, it's either super light or very dark, so we can't really see the edges of it. But later on, we will light up our scene and you'll be able to see it in more detail. Perfect. So now we have created this section where we have a title, we have a canvas where we're displaying something, and then we have controls where we can actually modify the global state and change the values so that the canvas interacts with what we're changing. Now in the next lesson, we can focus on rendering not just the box, but the actual 3D MacBook model. Let's turn this cube into a MacBook. Thankfully, we already have a model for it within public, models, MacBook 14.glb. This is a 3D file. But before we can use this 3D model inside React 3 Fiber, we need to convert it into a React component. And for that, we'll use this gltf 2JSX package. What it does is it takes a 3D model and just through the terminal, it converts it into a nice React component. So back within our terminal, navigate over into /public/models. Here, you should have all the different models. And then run npx gltf JSX MacBook 14.glb -T. This command will convert the MacBook 14 GLB file into a React component, and the -T flag will flatten the transformation, giving us a cleaner structure. If you press enter, it's going to ask you to install that package. So press Y, yes. And if it needs some additional permissions, you can add sudo in front of it. But in this case, we're good. It looks like it generated a new file. So let's check it out within our application. It's this MacBook 14.jsx, but now we want to move it within a new component that's going to be within the components folder. So within components, create another folder and call it models. This will be for our 3D models, and then simply drag and drop this model within the models components. Here it is. And it's going to look something like this. Now, we want to apply some changes to it, such as renaming it from model to MacBook Model 14. And we can also export it as a default function. So we can say export default function, MacBook Model 14, because it's the only thing we'll be exporting from this file. Then we need to update the model path, use gltf, coming from /models /MacBook 14 transformed.glb. Let's make sure that exists by heading over to models, MacBook 14 transformed.glb. It is here. And then we also want to apply a texture to this laptop by saying const texture is equal to use texture / screen.png. This allows us to add some kind of a screen image over to this model. Then we have all of these different meshes or geometries that together make this model. The only mesh we need to change is going to be second to last one, this one right here, 123. I want to expand this one so it's not a self-closing div. And within this mesh, we want to display a screen. Don't ask me how I know this. It's impossible to tell just by the numbers, but you had to just render the model before and then see that under 123, that's actually the screen. I'll show you later on what happens when we change it. So here, I'll render a mesh basic material, which allows us to apply a map of the texture coming from the screen image, just like this. And then at the bottom, you say use GLTF preload / and you have to change this to models MacBook 14 transform GLB. Perfect. And now before we check it out, let's quickly do the same thing for the MacBook 16 code. We're still within the models folder within our terminal. Run npx gltf jsx macbook 16.glb -T. Press enter, and it'll very quickly generate a new component. It's right here, so you simply need to drag and drop it into source components models right next to version 14. As before, we'll have to make some small adjustments to it, such as modifying the path right here by saying / models / and at the bottom / models / MacBook 16 transformed. And we can also use the texture by saying const texture is equal to use texture / screen.png. Now we can use that texture right here within the 123 mesh, which is actually the screen, where we can apply a mesh basic material, which basically allows us to render an image through a map of texture coming from our screen.png. And one more time, we want to follow the same process for the last model, MacBook GLB. We'll use this one later when we implement a section where the MacBook texture changes as we scroll to the bottom. So as before, just run this, but instead of saying 14 or 16, just render it like this, and then drag and drop this new model into the models folder. Don't forget to change the path to / models, as well as right here. And then later on, we can change the texture. For now, let's put the two models, the 14 and 16, to use right here within our product viewer. Instead of rendering a box, we'll render a MacBook model 14, pass to it a scale equal to 0.06 and position equal to -1, 0, 0, and self-close it, and make sure to import this model at the top from where we created it. You can pass any 3D props to the MacBook model because if you take a look at it, it expects all the props and just passes it down to the 3D model. Now, if you reload, you'll be able to see the model right here, but it's a bit dark. So if we try adding some kind of an ambient light, maybe with an intensity of 0.5, that'll light up the keyboard a bit more. So it's not super dark. Maybe for the position, we can keep it 0, so it's centered. There we go. And if you increase the light a bit, like let's say to 1, you'll see that it refracts the light a bit differently. But of course, we're still not quite there yet. The model is there and we can move it around, but take a look at the final version. It is much more polished. Making it go from this to this has a lot to do with lighting it differently. So let's do that next. Let there be light. We'll create a lights component that defines all the lighting for a 3D scene. It'll use a mix of environment lighting and spotlights to achieve an Apple-like studio photography look. Go ahead and create a new file within the components folder and call it studio lights.jsx. Run rafce, and then go ahead and import it right here within our product viewer instead of the ambient light. If you do it just like that, it'll break because we're trying to render a div within a canvas, which doesn't work. Lights have to be parts of the canvas as well. So I'll turn it from a div to a Three.js group with a name of lights. That on its own won't do anything, but it'll fix our view. And within it, I'll create a new environment coming from React 3.js. This will wrap the scene with lighting. And if we give it a resolution of 256, it'll add subtle reflections to metallic and glossy surfaces. Resolution of 256 is balanced for performance and detail. Within it, let's render another group. And within that group, we can render something known as a light former, coming from React 3.js. It's a self-closing component. This will simulate a large, soft, rectangular studio light. Apple often uses these softbox lights to highlight product edges without harsh shadows. So let's give it some properties, such as form of rectangular light, intensity of 10. Let's give it a position of -10, 5, and -5, a scale of 10, and if you save it, you can see that it's kind of coming from the left direction, right? Yeah, it's coming from there, definitely. If you change it over to 10, it'll be coming from the right, or maybe far right. It's too far. What if we bring it a bit closer? 20. Yeah, you can see how it's starting to light up a bit more. Perfect. We can also rotate it a bit by giving it a rotation -y of math.pi. And yeah, you'll have to use a lot of radians and degrees in Three.js and divide it by 2. So we just give it some rotation. I will now duplicate this and create another light former with the same intensity, but with a different position. It'll be 10, 0, 1, coming from the right side. And this will now properly light up the entire model. Beautiful. We could call it a day right here, but I also want to teach you how to add some spotlights. So create a new spotlight with an angle of about 0.15, a decay of 0, intensity of math.pi times 0.2. And now if you reload, you'll be able to see that there's going to be a new light coming in. Maybe we can remove this environment so you can see just the spotlights. It seems like it's coming right at this spot. If we increase the angle to maybe like 1, you can see that it's much larger, but I'll bring it back to 0.15 and I will position it a bit differently by giving it a position of -2. So you can see that this dot will now move off of the screen. I'll also give it 10 and 5. And now we can see how it's hitting the screen from the top. Pretty cool, right? Now let's duplicate it 2 more times. For the second one, I'll change the position to 0, -25, and 10. There we go. So now it's coming from the bottom a bit. And also the last one, I'll change the position to 0, 15, 5. And now it's also coming from the sides. Again, you can play with this and come up with something that looks and feels the best for you. In the last one, I'll just change the decay to 0.1. And I'll increase the intensity from 0.2 to 3. So this way it'll shine even brighter. But again, feel free to modify it however you like. And now if we bring back our previous studio lighting alongside these spotlights, it'll feel like a more complete look. Maybe we can decrease the last spotlight just a tiny bit. And there we go. Take a look at this. Beautiful. So now you get the idea that it's not only about the models themselves and the meshes, or even displaying a specific texture on a mesh. So this was the default. You can see how it wasn't high res, but we ended up adding this more higher res texture on the screen to get something like this. Hopefully that makes sense. But yeah, it's not only about the meshes and geometries and materials. It is also about lights. Because if we now remove the studio light component, we don't have anything besides the screen. But if we bring it back, it looks great. Perfect. Congrats on adding the lights. In the last lesson, so far, we've loaded up our 3D model and added the lights. But now we'll animate it so that when you move it around, it always returns to the center position. And you can also switch between different sizes. We'll do that using GSAP. So open up your terminal and run npm install GSAP and at gsap/react. Alongside that, we'll also need another small package called React Responsive, which is used to apply conditional animation logic and layout depending on different screen sizes that your users are on. So just install it. After that, we need to register our GSAP plugin. We can register it within the app.jsx because that's our entire application. So right at the top, just import scroll trigger coming from gsap/all. And also go ahead and import GSAP coming from GSAP. These two imports are importing the main GSAP library, as well as bringing in the scroll trigger or any other plugin like maybe split text that we'll be using throughout the application. Scroll trigger will let us animate things based on the scroll position, such as pinning, scrubbing, and triggering. And yeah, GSAP plugins aren't automatically active. You have to register them. So adding this single line, gsap.register plugin, and you can say scroll trigger right here. Later on, we might want to add a split text. Make sure that your plugin is globally accessible across your entire application. So putting it in app.jsx is a great choice. With GSAP installed, we are ready to create a new file. And this one will actually be a Three.js component. So under components, I'll create a new folder and I'll call it 3. Within 3, I'll create a new file called model switcher.jsx, which will handle the transitions between two different models. It'll be responsible for rendering both MacBooks, 14 and 16, detecting the size from the user UI, and animating transitions between the two models using GSAP. It'll also implement something known as presentation controls, which will allow users to rotate and inspect the MacBook in 3D. So first things first, before we even add anything into this model switcher, let's go ahead and import it right here within our product viewer by saying import model switcher from .3/model switcher. Oh, and I just noticed Studio Lights are a Three.js component as well. They're not a typical div. So I'll also put the Studio Lights within 3. And yeah, make sure to also change the import. Once you import the model switcher, we will render it right here within the canvas. That's the difference between regular components and Three.js components. Three.js are within the canvas, and they can't be a typical div. They either have to be a mesh or a group. And instead of rendering these basic orbit controls, I will now render a model switcher as a self-closing component, and we have to pass a prop of scale to it. Now we'll change the scale depending on the screen size we're on. For that, we'll use that responsive package that we installed not that long ago. So I'll check if we are on mobile, and if that is the case, we can check it by using the use media query hook coming from React Responsive. And the query that we'll check for is max width is 1024 pixels or lower, since we're using the max width. This means mobile or tablet. So if we are on mobile, we'll check that right here. And if that is the case, we'll provide a scale of minus 0.03. Else, we'll provide a full scale. This will make it look better on mobile and tablet devices. So now let's go over to model switcher and let's develop its functionality. First things first, run rafce to create a new functional component called model switcher. Then accept a prop of scale. Oh, and we can also accept the isMobile prop here. So let's go ahead and pass it over from our product viewer. IsMobile is equal to isMobile, just so we don't have to call the hook one more time. And alongside getting these two props, we can also create new references. Small MacBook ref is equal to use ref, as well as a large MacBook ref is equal to use ref right here. Use ref is obviously coming from React, so make sure to import it at the top. There we go. And now we'll have to choose when to show a big one or when to choose a small one, depending on the scale. So we'll say const show large MacBook If the scale is equal to 0.008, this will be set to true. Or if the scale is equal to 0.05, then this will be set to true as well. Now, within JSX, I will render an empty React fragment, and within it, something known as presentation controls. Within them, I'll render a group with a ref of large MacBook ref. And within that group, I will render a MacBook model 16, which we have to import from the right file. Let's try to find it within models, MacBook 16. Did we change the name right here? Oh, I forgot to rename it and to export it as default. That is very important. So just do export default function, MacBook model 16. And you can do the same thing for this one. Export default MacBook model. Perfect. So now, if we head back, you can now import that 16 version. And to it, you can pass the scale of if is mobile. In that case, you can pass a 0.05 scale. Else, you can pass 0.08 scale. This is just to make sure it looks good on all different screen sizes. I will now duplicate this presentation controls right below. We'll render the small MacBook ref. The smaller one is the 14 model, and the small is 0.03 on mobile and 0.06 on desktop. So now we can see so many models right here. Definitely not what we want, right? But I think this just shows you that we no longer need just a singular model, MacBook 14, right here in the canvas, because now this model switcher will render different models depending on what we click on. So to both of those, let's pass and spread the controls config. This controls config will be an object where we can define how we want to move around this 3D model. Right now, nothing is applied. And maybe instead of showing both, let's just show one for now. So I'll comment out the other. So now you can see that you can move it around however you please, and it stays that way. But you can give it a very simple property of snap to true. What this will do is it'll snap back when released. So now if you move it around and you release, it goes back. So even if you mess with it a lot, it always gets back to the frontal vision or to the general position. You can also pass the speed in which you can slide it around. Zoom is there as well. All of that works normally. Now there's a polar angle, which we'll set to math.pi or minus math.pi and math.pi. Now what this does, you can think of these as vertical rotation limits. If you bring the polar back, you can actually slide below and see it. Whereas if you remove the polar and reload, you cannot go any more down. Which maybe I even like, because you'll never be looking at the bottom, you'll be looking at the sides. There's also the azimuth, which is the horizontal scroll, which I'll set to minus infinity and infinity, which means that you can slide horizontally however much you want. There we go. And it'll always go back. Let's see how many circles can we make it make. Oh, okay. Pretty cool that it doesn't rotate in as many circles. It just gets back one circle, right? Amazing. And you can also set up some additional physics, such as config is set to mass of 1, tension of 0, and friction of 26. What this does is it tries to replicate real-world physics as you move this device around with mass, tension, and friction. Now, let's create some helper functions right at the top of this model switcher that allow us to fade the different meshes and move the different groups. I'll first outline some constants, such as the animation duration, which I'll set to 1 second. Same for the offset distance. I'll set it to 5. This offset distance is how far one model will move off screen when it's hidden. I'll create my first utility function called fade meshes. It'll accept a group and the opacity, and it'll open up a function block where we first check if a group doesn't exist, we exit out of the function. We just return. But if a group is there, we want to traverse all the elements within the group, get access to each of the children like this, and then for each one, check if child has a mesh, then we can change the mesh of that material to transparent by setting it to true, and then use the GSAP property .to on the child material to apply the opacity throughout a specific duration that will be set to animation duration. And this has to be within an object. GSAP, of course, has to be imported from GSAP at the top. And what we're doing here is we're setting the material to transparent at the start, but then we'll animate it slowly so that it looks like it's coming to life. Then we can do a similar thing for moving the element by saying move group is accepting a group and the X, and this will allow us to animate the horizontal movement of a group. As before, we'll check if a group doesn't exist, then we'll return, but if it does, we'll use GSAP to animate the group position to the following X position over a following duration of animation duration. I'll collapse these two functions, and now we'll be able to use these two utility functions within something known as use GSAP, which is a custom hook coming from GSAP React, making it easier to work with GSAP within JSX components. So right here, above the controls config, I'll define the use GSAP hook, and like useEffect, we can make it run whenever something in the dependency array changes. In this case, whenever the scale changes. So right here, we want to animate the movement of a group from a large to a small MacBook. Right now we're in 16, so I'll say small MacBook ref dot current to get the current position, and we'll move it by the offset distance, so minus offset distance, or move group large MacBook, we'll move it to the position of 0. Then we can also fade out the small Mac and fade in the large Mac as it is moving. So I'll say fade meshes. I'll fade in the small MacBook ref dot current to 0, and we'll fade in the other one, which is the large MacBook ref. We'll fade it over to 1. And we have to do the same thing, but if we're currently showing the small Mac. So I'll say if show large MacBook is true, then we want to run all of these. But if we're currently showing the small MacBook, then we want to do it the other way around. So I will duplicate all of this, but we'll change the values to small MacBook ref dot current to 0, and the other one will move it by the offset distance. And we want to change the opacity to small to 1 and large one to 0. So now if I save it and reload, it's currently on 16, but if I move over to 14, it slides away and a new one should technically appear. Oh, and wait, it will as soon as I comment this one in, because that's the 14 model. So one more time, 16 slowly fades out to the right, and 14 slides in from the left. And you can see that now we have a full presentation of controls over the two models that we can switch between and move around. Next up, we just have to change the color. To change the color, we can head over into one model and then the other, and then apply that color. So head over into MacBook 14 models, and then we'll have to extract that color from the global state by saying const color is equal to use MacBook store, which you will have to import right here at the top, coming from store index.js or just coming from store. Then we'll also need to get the scene from our transformed GLB model, and then we will use a use effect to apply that color across all of the different meshes. I'll say use effect, create a new callback function, and run it whenever the color changes. In this case, it'll change whenever we change it right here. What we want to do then is call the scene and then traverse through it. We then want to get access to each child from the scene, and for each one, we want to check if that child is a mesh. And then here, we want to change the color only if the part name is not in this list that I called no change parts. So what is this no change parts? Well, it'll come from constants. So head over into constants index.js, and alongside this nav links, we can also export and create no change parts. and this will be an array. Just so we don't have to write it down manually, you can find it within the video kit down below. If you scroll down under snippets to copy, you can copy the entire constants index.js and override what we have right here. You'll notice that here, I created an array of different names to which I do not want to apply the color. I manually went through every single mesh and I checked whether that color is an outer part of a MacBook. If it is, we want to change its color. But if it's the display or something else, then we don't want to touch it. So now that we have this no change parts, and now that we're exporting it from the constants, we can now import it right here and say if not no change parts dot includes the child name. In that case, we want to change the child.material.color to be equal to new 3.color, and want to apply the color that we're passing right here from the state. Now, before you save it, make sure to import 3 by saying import everything as 3 coming from 3. Or in this case, we're just using the color functionality, so you can say import color from 3, and then you can do it like this. Now, if you want to test it out, we need to switch over to the size that we made these color changes on. Right now, we've done the changes for the MacBook Model 14. So if you switch over to 14 and now test it out between light and dark, you'll be able to see the difference. Let's make it work for the larger model as well by copying this part entirely, heading over to 16, and then just pasting it over here. Make sure to import the color from the MacBook Store, get the nodes, materials, and the scene coming from MacBook 16 this time, and then get the texture. After that, we apply the use effect across all the different meshes, but only the specific ones. And this means that we can now change the color for both MacBook sizes. Now that that works, we can now remove this piece of text right here that is right here within this product viewer. And we can now just say MacBook Pro available in 14 and 16 inch variants in space gray and dark colors. Perfect. You can keep it like it is, or if you want to, you can totally remove that piece of text and just keep the switcher. Perfect. And of course, keep in mind that this looks so much better on a larger screen where these colors and sizes can truly shine. Now, with all of those changes implemented, we want to run a new CodeRabbit session to see what it has to say about our code now. Now it has 4 additions, 7 modifications, many new lines added. So let's hit enter to hop into the review. Hopefully there are no ghosts of bugs pasts. Let's wait a bit more and see if AI really does know more than us. And there we go. As the CodeRabbit is reviewing your code, we can already see 2 potential issues that we can then expand. One problem is that we can avoid exact equality comparison with floating point scale values. If you press enter on that toggle, you'll be able to see more info about it. It says here that using triple equality with 0.08 is fragile because floating point arithmetic can introduce precision errors. If the scale value comes from calculations, animations, or user interactions, exact equality may fail unexpectedly. So it's always better to use thresholds, or if we know for a fact that these points are going to be exactly as they are, and we do know that because we have set them up, then it's better to define those scales as constants. And now we have a couple of options. We can either close the details, copy the prompt to fix this with AI, or apply the suggestion, or reject the comment. In this case, the change is super simple, so I can go ahead and implement it manually by copying these couple of lines, heading over to the model switcher, and then right here at the top, we can define different scales, and then just modify this line to use these new constants. With that, our code is more predictable and descriptive. Going back to the terminal, let's now collapse this issue because we fixed it, and let's head over into the first issue right here, where it says that we need to add a missing dependency to the use effect. The scene object is used inside the use effect, but not included in the dependency array. If the scene reference changes on model reload, the effect won't rerun with the current color. That is actually a super nice suggestion, and I just pressed the letter A, and it seems like it fixed it on its own. Let's head over to the model 16, and there we go. The scene got added. That's great. We can also do it for the model 14, where we can add the scene. Now we can head over to the next issue within our index, Here we have some inconsistencies within the text. This one for sure I will automatically fix by pressing the letter A. And then finally, the color typo in the reset function. It resets the color to 2E2C3E, but the initial color is 2E2C2E, so it's a bit different. So let's go ahead and auto fix it. If you head over to the store, this actually shows you that you can completely change the color of the model if you want to. So if you want to change it to something entirely else, you can do that. Like this is a nice greenish color, and you can see how differently this MacBook looks like. You can go with something much different. Let's go with 3/7. And this actually gives us a nice grayish color. Or if you want to go with something darker, this works too. So if you want to add multiple colors, feel free to do that. This was a great catch and definitely not something I would have noticed on my own. So now we can go back to home, and with that, all of the suggestions had been implemented, which means that we're finally ready to push our code to GitHub by running git add git commit -m, implement 3D product viewer section, and git push. And just like that, our latest changes have been pushed over to GitHub. In the next lesson, when we implement the next section, I'll show you how you can also use CodeRabbit when we open up a PR from a new branch. CodeRabbit CLI is great for getting the fixes directly within your IDE, but where it truly shines is within PRs. Now, the next section we'll implement is this amazing video playback that shows you the M4 chip, allowing you to play those demanding games on that powerful MacBook. So since this section will be a bigger one, and for sure we'll need a PR review when we finish it, let's go ahead and immediately create a new branch by running git checkout -b and call it showcase. This will automatically switch you to a new branch, so we can dive right into it. Okay, here's the hero section. Here's the 3D model viewer, and then right below it, we'll have a showcase section. A section that opens up a full screen video, on top of which we'll display an overlay that'll show the user what powers this game. And that is a very powerful Apple M4 chip. And then we of course show some more info about it. So let's get it developed. I'll start by creating a new component within the components folder, which I'll call showcase.jsx. I'll then run rafce to quickly spin up this new showcase component, and then we can import it within app.jsx right below the product viewer. There we go. Here is the showcase. Heading right into it, we can start developing its UI by turning this div into a section that has an ID of showcase, so we can actually scroll to it from the navbar. Then within it, I'll render a div with a class name equal to media, because within here, we'll play this video on repeat. We'll use a regular HTML5 video element that'll have a source of /videos/game.mp4. So as soon as you do this, you'll be able to see what appears to be a photo, but is actually a video. And since this section is very visual, I want to expand it a bit so we can better see what's happening. I'll set it to loop, I'll make it muted, and I'll make it autoplay as well as plays in line. That way we don't have any kind of controls to scrub the video. Rather, we'll play and pause the video depending on the scroll. That's where GSAP comes in. So now if you reload, you'll be able to see this beautiful video, which has to be high res because it's showing on full screen. Now, with that in mind, I want to apply a mask on top of that video. So right below this video element, create a new div that has a class name equal to mask, and within it, a self-closing image with a source of mask-logo.svg. So typically, whenever you are applying masks, you're using SVGs because they're super easy to show on top of other content. Right now, that mask is dark and it is right here below. So you can see how it looks like if I click and hold and then drag and drop it over it. We want to align this and make it cover the full screen and make it show as we scroll. But while we're here, let's also pause this video for a second, just so it doesn't continue scrolling. And let's implement the section below the video. So we'll go below these two divs and create a new div with a class name of content, another div right here with a class name of wrapper, and then another div right here with a class name of, on large devices, maxWMD. That way it won't take the full width of the screen, rather it'll stay in the middle. I'll give it an H2 and I'll call it Rocket Chip. It's super fast. Then below it, I'll render a div with a class name of space-y-5, margin top of 7 to divide it a bit, and padding PE, that's inline end, 10. Now within it, we can display another p tag and say introducing, then we can put a space, then still within this p tag, but now within a span that'll have a class name of text-white, we'll display M4, the next generation of Apple Silicon. And then after the span, I'll say dot M4 powers. Then, continuing with the rest of the UI, we can create another p tag right here, and we can compare it with the final website. If you scroll down, you'll see that here text is much bigger, and I'll copy both of these paragraphs. I'll start with the first one, and then I'll create another p tag below it, and I'll paste the second one. Finally, below that second p tag, we'll need to create another p tag, which could technically be an anchor tag, with a class name of text-primary, and within it, I'll say learn more about Apple Intelligence. Finally, we just have to create these two small sections up to 4 times faster pro-rendering performance than M2. So let's do that by heading 2 divs down, 1 and 2, create another div to encapsulate that section with a class name equal to maxW of 3xs and space-y-14, and then 2 more divs, each for its own section. One with the class name of space-y-2 to create some space in between the elements, and then a p tag that says up to, below it, an h3 that says 4x faster, and then below it, another p tag that says pro rendering performance than M2. And we can say 4 times faster pro rendering performance. This is good. Now we can duplicate this just below. And for this one, I'll say up to 1.5 times faster CPU performance than M2. So now if we head back over to our current application, it'll look something like this. This is just plain structure. It's plain text and elements that we can then animate. So let's start with implementing this stunning video mask effect. Right at the top of this file, I'll first get access to the isTablet variable, and this will be equal to useMediaQuery. Remember that React responsive package we installed, which allows us to figure out on which device are we loading this application. For this one, we want to know whether it's tablet, so we'll trigger it when the max width is smaller than 1024 pixels. And now we can put GSAP to use by using the use GSAP hook, within which we're going to check if we're not on tablet, then we can start applying the animation. Of course, we have to keep track of the changes in the isTablet state, and every animation starts with a timeline. We need to move something through time. So say const timeline is equal to GSAP, which you have to import right here at the top by saying import GSAP from GSAP dot timeline. Then to it, you can pass some additional options, such as scroll trigger. We want to trigger this animation or this timeline not on click, but rather when we reach the showcase section. Specifically, we want to start it when the top of the screen reaches the top of the section, and we want to end it when the bottom of the screen reaches the top of the section. We want to apply a scrub set to true, so we're actually animating the timeline with our scroll, and we'll also pin it. So now that we have this timeline, we can call it by saying timeline.to.maskImg. So we're now animating something within that timeline. In this case, we're targeting this div image element, and you can define what you want to modify for that element. In this case, we want to transform it. So I'll run transform, and the transformation we want to apply here is a scale of 1.1. So we're going to enlarge this image. And I'll also apply another .to function, in this case to the .content element, where I'll set the opacity to 1, y position to 0, with an ease of power1.in. Then I will autoplay the video. And now before we go ahead and test it out, I just noticed that I made a small mistake right here. The ID here should be showcase. If you fix that, all the contents within it will show more nicely on the screen. And on smaller devices, this won't scrub on scroll, but immediately the mask will be on top of the video. But now check this out. If we enlarge the screen, reload, and start scrolling down, you'll notice that now you'll see the full game and you'll be like, what's happening? We're looking at Assassin's Creed here. But as you continue scrolling, it'll all start making sense because this game can actually run on your M4 rocket chip. Yep, that's the newest generation of Apple Silicon. Pretty cool, right? It's such an effective section that nicely complements the first two sections we've created. So with that in mind, let's go ahead and commit it by running git add dot git commit -m showcase section and git push. Since we created a new local branch, you also have to set it as a remote branch. You can do that by simply copying this git push set upstream command. And then back on GitHub, you'll see that the showcase branch had a recent push about 24 seconds ago, so you can compare it and open up a pull request. In production apps, you never push straight to main. You implement the features on your feature branches and then open up a pull request. And that's exactly what I want to teach you right now. So create a pull request, and if you go under files changed, you'll notice that we haven't really pushed the right changes. Back within our application, it seems like I was inside the models folder, and you always want to be within the root of your application when you're pushing it over to GitHub. So once again, run git add dot git commit -m implement showcase section, and then git push. This will now push the right changes over to GitHub with 11 file changes, and it'll give CodeRabbit plenty of code to review. And it looks like it already hopped on to do that. It may take a few minutes, so let's give this rabbit some time. We'll have to trust its mommy saying that it's the best code reviewer out there. Okay, first things first, CodeRabbit provided this nice summary where it says that we implemented a couple of new features. We introduced an interactive 3D product viewer with real-time color and size controls, responsive layout, and smooth model transition. And we added a scroll animated showcase section with pinned media and content reveals for an immersive viewing experience. Okay, so let's see the comments it came up with. There's a couple of nitpick comments, which are very small and you don't have to necessarily fix them, such as fixing placeholder links in the footer, or removing unused imports, or maybe memoizing the color, so we don't have to create a new one every time. But on top of these nitpick comments, there's also some major ones. And what I like about CodeRabbit is that it provides you with a complete analysis chain on how it came up with this review suggestion. It's suggesting to use sRGB color space so UI imagery isn't washed out. And it even provided an alternative if we're using an older Three.js version. Now, here are two super easy ways in which we can immediately implement these suggestions within our code. One is the committable suggestion, where you can review the snippet to be added, and you can automatically commit it to the code. The other one is a prompt for an AI agent to fix it for you. For this one, let's go ahead and commit it automatically by just saying commit and commit changes. There we go, suggestion applied. And it's going to update itself so that it's resolved. This was within MacBook 16. So if you head back over to your application and run git pull, you'll be able to see that there's going to be a new pull on MacBook 16 with the implemented change. So head over to MacBook 16, and you can see that now it's using this sRGB color space. But of course, always make sure to check what you're auto importing. In this case, the imports have to go above right here. And then inside of the component, we're using this texture and applying a color space to the texture. And then we have the rest of the code. And if you take a look at the screen right here, it's using the sRGB color space, whereas the V14 isn't. And if you're still not sure what these two lines do exactly, select them, press Command-Shift-B, and type Junie. If you don't have Junie installed, go ahead and install it by clicking the link in the description. But if you do, you can just ask it, what do these two lines do? And just like that, we got a short answer. Texture color space sRGB color space tells Three.js that the pixels in screen PNG are in sRGB space, so they should be gamma decoded on upload and displayed with the correct color management. No washed out or overly dark colors. And the needs update flags that the texture's parameters changed, so Three.js should re-upload the texture to the GPU on the next render tick. Otherwise, the color space may not take effect immediately. And now if you need a deeper explanation, it gives it to you here. But in simple words, we're doing this so that the color on the screen isn't washed out or using overly dark colors. This is a nice catch by CodeRabbit. So let's go ahead and apply it to MacBook 14 as well by copying these two lines, heading over to MacBook 14, and just pasting them right here below the texture, and make sure to import the sRGB color space. Now back to CodeRabbit's review. It has something to do with the use effect, in which we change the color of the meshes within the MacBook model. It says that this is a major issue where we need to clone the per mesh materials before recoloring to avoid cross-part bleed. Shared GLTF materials will recolor excluded parts if reused, clone once, and then set the color. Okay, that's nice. We immediately get a committable solution. But before we commit, let's also add and push the changes we have within our code, just so we don't have any conflicts, by running git add dot, git commit -m, add sRGB color space, and git push. But it nicely noticed that the diff is outdated, so we need to refresh and then try again. There we go. But in this case, I believe that this change isn't necessary, and rather, if we implement this, the color switching on our MacBooks will stop working, so we won't proceed with this suggestion. There's another suggestion saying that we shouldn't pass both the material prop and the child material, because the child won't reliably override. And I think this is true. This has to do with changing our screen, where we're applying the texture of what's being shown in the screen, but here we're also applying an additional material, and here we're adding a child material. So if I remove this material on the outside and head back, everything is still working as it did before. But now we don't have to be scared that it'll mistakenly render just this material instead of the child material, which is the actual screen. So I'll remove this material from the parent, both on version 14 and version 16. Perfect. Let's see what else we have. We have the constants here saying that we can add CSS definitions for box 1 and box 2. No matching selectors found. No, they should be there within the index.css file. So I believe with those changes implemented, we're good to go. But let's just not forget to commit our latest change by running git add dot, git commit -m, fix material override, and git push. With that done, all the checks have passed and we are ready to merge this PR into the main branch. Perfect. That's it. Oh, and while I was reviewing this PR, CodeRabbit also gave me a complete walkthrough of what we're implementing here. It split the changes by cohort and gave us a summary for each one of the files or the cohorts of files. For example, we have these 3D models, and sure, we know what those are, but if somebody else is reviewing our codebase, it's super useful to get a very quick answer that these are GLTF components, and through them, we can apply store-driven colors across meshes. Then the model switcher is toggling between the large and small MacBook, and then we're using GSAP to move those around. And check this out, there's even a sequence diagram where we can see how a user can interact with our app. The user first loads the app, then we render the product viewer, which then reads from the store the color and the scale. The user can then change the color and the scale using the setter function. They set it, we update it, we apply colors, and finally we animate the positions using GSAP. It's so nice to have a visual representation of what we just implemented. And then here's the part for the showcase. I would have thought that it's impossible to show this using a diagram, but hey, you render it, we register the scroll trigger, we pin it to the screen, and then as we scroll or scrub the timeline, then the mask scales and the content fades and translates. Once again, it's super nice to see this visually. And at the end of the day, we're even getting a poem. This is not just auto-generated, but rather it's connected with what this PR just did. Three.js dreams and silver sheens, GSAP winds that softly glide. I flip my lid, colors bloom, a hop, a click, a state renewed, showcase and viewer imbued. Okay, well, that's quite something. So with that in mind, the changes are now here. These great sections have been implemented, and now we can move to the next section. Next, we have this next level graphics performance, where many different screens will reveal the MacBook in the middle. So back within our code, let's first run git checkout and move to the main branch and pull all the latest changes. Then we can create another branch either for the next section or we can create one for sections to come. In this case, I'll do that by running git checkout -b and I'll call it finalize landing page. Now that we switched over to that branch, we are ready to get started with implementing it. Just below this rocket ship, we'll focus on implementing the performance section next. So within the components folder, create a new file and call it performance.jsx. And you can also use RAFCE to quickly spin it up. Then back within the app.jsx, you can just render it below the showcase and call it performance. As a matter of fact, we can create all the other components that we'll also be using throughout the rest of this application. The next one will be called features. So let's implement a new file and let's call it features.jsx. You can also run RAFCE to quickly spin it up, import it within the app. Then we'll have a highlights section .jsx where you can run RAFCE and also import it within the app. And finally, we'll have the footer. That one is simple, so just create a new file, call it footer.jsx, run RAFCE, and then import it within the app. Perfect. 4 more sections to go. If you now start scrolling down, you'll see 4 different pieces of text, one for each of the sections. So let's move over onto the next one, which is performance, and let's start implementing the UI. I'll first turn this div into a section and give it an ID equal to performance so that we can scroll to it later on. Then I'll create a new H2 and just copy what the official website says. Next level graphics performance, game on. Below that, we want to render all of these images. We can do that by creating a new div, which you can call wrapper because it'll wrap those images. And within it, we can map over those images. I already stored them within the public folder and mapped over them within the constants index.js. So you can just import them from there, and you can see that each image has its own ID and the source. So now you can just run that map for each image. You can automatically return an image element with a source equal to image.src, an alt tag of ID, and we can also give it a key equal to image.id. And since we're mentioning image.source and ID too many times, we can just destructure it right here by putting it in curly braces. And that way you don't have to repeat yourself and say image dot every time. Now, if you do that and head over to desktop, you'll see all of these images one by one being rendered right here. Below those images, we want to display some content. So I'll run a div with a class name equal to content and a p tag. Here, we want to display some text, such as this one right here. And specifically, we can highlight one sentence, one that says that gaming feels more immersive and realistic than ever. So that one, I will put within a span element that has a class name of text-white. So let's nicely enclose it within this span element. And if you do that, you should be able to see the text somewhere here if it's not hidden by the images. And we also have to create an extra space right here before the span and then after the span to connect it with the rest of the text. Now we'll animate this text and the images. But for this section, I want to try something different. I wrote a prompt and I want to try to give it to Junie to see how well it does. So just press Command-Shift-P and open up Junie. We can start a new session, and this time we'll allow it to code. I'll give it access to a specific file as the context. In this case, we're working on the performance section, and I'll paste the prompt that I wrote. I will leave this prompt as well as the final output in the video kit down below, so you can test it on your end, and if something doesn't work, you can always just use the final code. Now let's go through it. Junie, I need some GSAP animations added to the performance section. Here's what I'm after. The paragraph inside the content should fade in and move up slightly as it scrolls into the view. On desktop, I also want the performance images to animate into their positions using a scrubbed scroll timeline. Each image should be targeted by its ID class, and their final positions should come from the constants. On mobile, only the text animation should run, no image timeline, use GSAP with the section ref for scoping, and so on. The end result should be a smooth text fade slide as you scroll. In the desktop, the images settle into place in sync with the scroll. So let's see how well Junie does. Before it starts writing the code for you, it actually goes through the project and tries to understand what's happening. It's opening up index and CSS files just to get a better understanding of the codebase. And only when it reviews it, it then updates the task progress. Because now it knows exactly which images we're talking about, what are their final positions, and it's diving into implementing the animation. So it's editing the performance file as we speak. You can review all the changes in real time, and now it's including the triggers. I'll give it some more time to finish it before we check it out. And there we go. In real time, as I was speaking, it implemented GSAP animations for the performance section with scoped section ref. So now if you open up the performance section, you'll see that right at the top of the component we implemented, we now also have this use GSAP hook. In this case, we don't have to register the scroll trigger plugin because we've already done that in the app. But other than that, let's see how well it implemented the animation. Oh, and we do need the scroll trigger import after all to refresh the resize. So we can leave the import right at the top. Now, if I get back to the code and I start scrolling down, you'll see that it actually slides all of those images very nicely. It's still not yet perfect, as one of those images is the actual MacBook, which should remain in the middle so that the final application looks something like this. But I gotta say, Junie got very close with the animation. Now, let's go through it together and see where we can tweak some things. I'll first use this isMobileRef by using the useMedia query so that we know whether we are on a tablet device or not. By applying a query of max width of about 1024 pixels. Then, right here, we're animating the text. We're targeting the P element within the content and modifying its position. In case the only thing I wanted to do is to just modify the opacity and move it up a bit. So I'll make it start from the opacity of 0 and the Y position of 10, and then change the opacity to 1 and the Y position to 0. With an ease of power 2 out, the duration can remain. The trigger can be .content P, so when the top of that element enters the bottom of the view, and we'll end it when the top of that element enters the center of the view. And no need for these toggle actions. Rather, I'll just set the scrub to true, which means that it'll animate it as we scroll. And that is our text animation. So now if you reload and scroll down, you'll notice that the text actually scrolls in with the images. Perfect. Now let's look into the animation for the images. We want to make sure this is desktop only. So instead of doing this match media, which is indeed a built-in GSAP feature, we'll use that handy package by saying if is mobile, return, meaning don't apply any further animations. But if we are on desktop, we'll create a new timeline, TL, by saying gsap.timeline. Oh, it's already being created right here. That's good. And then for it, we'll apply some defaults, such as ease of power 1, .in out. We'll apply a duration of 2 seconds and a override set to auto. This will automatically handle the conflicting animations. For the scroll triggers, we'll use the entire section as the trigger. We'll start the animation when section top hits the bottom of the viewport, and we'll end the animation when the bottom of the section hits the top of the viewport. We'll set the scrub to 1, which will sync the animation with the scroll, direct sync, and we'll invalidate and refresh, which means that GSAP will recalculate trigger points whenever a screen gets resized. And now we need to animate each of the images to their final positions. But we don't want to do it for P5 because P5 is the MacBook image. If you head over to public and then see the image 5, you'll see that that is the actual MacBook. So that one we don't want to animate. So right here, I'll check if item or position.id is equal to P5, then just return, skip the animation. If you do this, and if we end everything properly, let's see whether we have closed everything. Well, I will remove this bottom part for now, just to make sure we're closing it properly. GSAP starts here, ends here, and then we'll add this scope and section ref later on. There we go. Now it's good. So if I scroll down, you'll now notice that the MacBook stays in the middle. So nothing is being applied on it. We just have to fix the animations a bit. So let's fix those positions. First, I will remove this initial offset. If you do that, you'll notice that there's no lowered opacity. All of them are at their full opacity. And then we're checking for different positions. We're checking if each one of these images has its position, like let's say ID with a P1 has a left of 5 and a bottom of 65. That's the ending position we want to apply to this element. So that's why we say TL, as in timeline, dot to this specific class name that we target. Then we apply the two variables. So that's this object that starts with y0 and auto alpha to 1, but we can also start it from a basic object. And then for each one of these, if a left position exists, then we move it that much percent to the left. If a right one exists, or if the bottom one exists, we do the same thing. And finally, if the transformation exists, we apply the transformations. Then finally, we apply all of those GSAP animations to that specific element. In this case, we can remove this return, and instead, to this use GSAP hook, we can give some additional options, such as the scope of section ref, which means that we're limiting GSAP queries to work only within this component, as well as we want to add dependencies. So whenever the is mobile changes, we want to recalculate the positions. So now if you reload and go back, and if you scroll down, you'll notice that now these images will nicely reveal the MacBook. But you can notice that after we pass this section, they continue getting farther away. But they should actually get farther away as soon as we are looking at the screen directly. And to do that, we need to change this part right here, where we'll say that we'll end the animation when the center of the section hits the center of the viewport. So now if you reload, check this out. If I scroll down, the full animation will play out by the time when we hit the center, and all of the images will be that much farther away, revealing the MacBook in the middle. And then as I continue scrolling, they won't be moving anymore, but rather the text will be revealing itself at the bottom. This is beautiful. So Junie definitely helped us a lot with coming up with this animation, but we also needed to do some work on our end to tweak the animations to come up with that real human touch. With that in mind, this section is done. And if you check it out on a tablet device and reload, you'll see that it also looks good. Well, you could tweak the positions of the screens outside to work good on smaller devices as well. But if you go to something like a mobile or tablet, it still looks like there's a lot happening, right? You can do so many things on this MacBook device. Again, if you want to make a bit more precise circle of apps around the MacBook, you can just head over into constants and then animate them to different positions depending on the screen size. You would maybe go something like this, desktop, and then you would put the left and bottom within desktop. And you can also apply different positions for mobile or for tablet, which would make it look great on all sorts of different devices. And then you can animate it over within that GSAP section that we just implemented. With that in mind, we can check it out with CodeRabbit by just running the CodeRabbit command and then pressing enter to see what it has to say about our changes. Looks like we only got two issues. One is in the footer, and we should be using the semantic footer element. Yep, we'll change that later on. And then the second one is in the performance component, where we need to use the alt attributes for the image's accessibility, which I entirely agree with. So we can just press the letter A, which will automatically apply the suggestion. Good. With that in mind, we are now ready to commit the changes by running git add dot git commit -m implement performance section and git push. Since it's a new branch, we have to set the upstream, so we push it over to our remote repo. We won't be checking out the PR just yet. We'll first implement the other sections to come, and then we'll do it at the end as one final PR check. Next up, see it all in a new light section, which will be the feature section of our landing page. We'll have the same MacBook model as before, but this time with an animated video screen. And then as you scroll, not only will we display additional features on the left and the right, but we will also rotate the MacBook to show in video on the screen what that feature is all about. This is an amazing use case and combination of both GSAP and Three.js. So let's do it together. Back within our code, now we want to navigate over to components and features. This is where we can turn it into a section that has an ID of features, and add an H2 that'll simply say, see it all in a new light, like on the design. But before we go ahead and display it, there are two things we have to do. First, we have to head over into our store. That's store index.js. And here, we will now be modifying the texture of the screen as we scroll, so we have to change it in the global state. For that reason, I'll choose the current texture, and we'll start with it being the videos feature number 1.mp4. But then we also have to have a setter function, such as setTexture, that allow us to change what's being displayed on the screen as we scroll. And also when we reset, we can reset the texture to be just the initial video. Perfect. Now let's go to the previously generated MacBook model. It's right here within Models, MacBook. Not the 14, not the 16, but just the regular MacBook. And here we want to add a support for the video texture. We can do that by extracting the color and the texture, which is the video, coming from or is equal to use MacBook store. Then from this use GLTF model, we also want to get access to the scene and make sure that the path is right. It's macbook-transformed.glb. Once that is done, you can say const screen is equal to use video texture. This is a very nice utility function provided to us by React 3.js, to which you can just pass a video. In this case, it's texture, because the path right here is coming from the store, pointing to an MP4 file. Then we want to do the same thing as we've done in the previous MacBooks, and that is just to change the color of it. So I'll copy this use effect and just paste it below, where we'll have the scene.traverse, check if it's a mesh, and if it is, we will change the color. And then of course, if you head over to the mesh 123 geometry, we have to remove the screen material and rather make it accept the child, which will be the actual mesh basic material that'll show the screen texture. Or in this case, it'll be just the screen. I believe that's how we called it right here at the top. And that's it. This now means that as before we rendered a texture that was an image, now we're passing over a texture that is a video, and that video is coming from a store, and we can modify it as we scroll. So let's develop it by heading over into features and creating a canvas within which we can display this 3D model. This canvas is coming from React 3 Fiber. It'll have an ID equal to F canvas, as in features canvas, and we can immediately play with the camera position of the element we'll show in there. For now, I'll just leave it blank. Pretty cool thing is that we already created a component called Studio Lights, which automatically lights up our scene. And we can also apply an additional ambient light of an intensity of 0.5. And then here below, we have to render our 3D model. Before we do that, let's just display a list of features that we want to display below the canvas. So I'll render a div, and that div will have a class name equal to absolute, because it's going to show outside of other elements in the screen, and inset 0. Within it, we can map over our features coming from constants. And then for each feature, we can automatically return a div with a class name equal to. It'll be a dynamic class name, so we have to import CLSX. And it'll always have a class name of box. But we also want to apply an additional class name depending on the index of the box we're rendering. So I'll get the index, and I will say dynamically give it a box and then index +1. So box 1, box 2, 3, and so on. And then also we want to apply some additional styles by saying feature.styles. Because within constants to each one of these images, we're positioning it in a different part of the screen. You can see that right here. Email is on top left, image is on top right. Then we have middle, summarize AI, and at the bottom, airdrop. These features won't show on the screen just yet because we have to animate them into place. So for now, I'll just render a piece right here that says feature.text. Even though it won't show yet, it'll show when we animate it in. So now we have to implement this 3D model. And to do that, I'll create a new component right here on top of our features, and I'll call it model scroll, because it'll be a 3D model that, well, scrolls. And it's going to be a React component on its own. Within the return part of that component, we can just return a 3 group with a ref equal to group ref. And that's a ref that we can create right here at the top by saying const group ref is equal to use ref coming from React, starting as a null value. Then I will load it within a suspense. That means that we can display some loading as it actually loads up, because here we're displaying a video component and it does need some time to load. Instead of just a regular fallback that says loading, we can now display HTML elements within a Three.js canvas. So for that reason, we have to give it a fallback and wrap it in HTML. That then allows us to render some HTML elements within a Three.js canvas. In this case, I'll just return an h1 with a class name equal to text-white, text-3xl, and uppercase, and I'll simply make it say loading ... Now, once the loading is finished, we want to display a MacBook model, the one we created, with a scale of, and now depending on whether it's mobile or not, we want to give it a different scale as before, so we can get access to this is mobile, and make it equal to use media query. And the media query we'll use is a typical tablet one, so that'll be a query of max width of 1024 pixels. And now if we are on mobile, in that case, we'll give it a scale of 0.05, a bit smaller, else 0.08. And we can also modify its position, where it displays on the screen. It'll be 0, -1, and 0. So we'll move it a bit down on the y-axis. And now we can render this model scroll right here within the canvas. If you do that, you'll see this loading that I was telling you about, and then a new MacBook that'll load with the video number 1 playing. But as we scroll, nothing will happen. So I'll drag this a bit to the right so we can still see the video playing. Let's make it tablet size. And now let's slowly start animating it. I'll first get access to the setter function called setTexture, which is coming from use MacBook store, the global store of our application. That'll allow us to change the video on scroll. Next, the first thing we want to do is preload all feature videos during component mount. That way, we can easily just modify them within the screen as we scroll down. So I'll run a use effect, and as soon as the component loads, meaning an empty dependency array, oh, and don't forget to import the use effect from React, we want to go over the feature sequence coming from constants, and for each one of these features, we're going to get access to it and immediately preload it. We can do that by creating a virtual video element in memory, which won't be added to the DOM. I'll call it V, and that'll be equal to document.createElement of a type video. This will allow us to start downloading the video data without displaying it. Then we want to configure the video element with optimal settings for smooth playback by saying object.assign, V as in video, and then we can give it a couple of settings, such as the source, which is going to be feature.videopath, muted, because we don't need any sound, plays inline to true. Inline here will be capitalized because we're in JavaScript. Preload will be set to auto, which means that it'll aggressively load all the data of the video, so it's ready to be played when needed. And then we'll also set the cross origin to anonymous, which will allow us to load videos from different domains, like a CDN. And then we can run v.load, which will start fetching the video. Perfect. So once we preload the videos, we want to enable the 3D model rotation on scroll. Remember this, how it rotates? Well, that's what we want to achieve. So right below, I'll open up the use GSAP hook, and we'll start with a 3D model rotation animation. And we'll also pass an empty dependency array to this use GSAP hook. Let's start by creating our first timeline, specifically for the model, so we can call it model timeline, and it'll be equal to GSAP, which we have to import from the top, dot timeline. So that's going to be import GSAP from GSAP, and then we can pass some additional options to it, which will be based on this scroll trigger plugin. We'll make the trigger the canvas itself. So as soon as the F canvas, the feature canvas, gets into the view, or rather, we'll start it when the top of that component gets to the top of the viewport, and we'll end it when the bottom of the component hits the top of the viewport. We'll set the scrub to 1 so that it is 1-to-1 matched with our scrolling, and pin to true. This will pin the canvas in place during the scroll, creating that scroll distance. So if you now reload, you can see how there's so much more scroll for the same thing. Now, once we have this timeline, we also want to sync the feature content. So different types of videos that are going to display different features. That'll be equal to timeline is equal to gsap.timeline based on the scroll trigger as before. And it'll more or less be the same thing as we had here. We'll simply have the scroll trigger. The trigger will still be the canvas. We'll start from top center, we'll end at bottom top, and we just want to scrub it, but not pin it. Perfect. Finally, we want to spin the 3D model by saying 3D spin. If groupref.current exists, then we have the model timeline that will animate to, and first you have to choose which target you want to animate. So that is the groupref.current.rotation. And to it, we'll apply some settings, such as the Y position of math.pi times 2. And what this does is it'll rotate it 360 degrees, or 2 radians, 2 times math.pi, around the Y axis. That means that it'll make a full circle. And we can do it with an easing, so ease of power1.inout. You'll see me use this one often. Perfect. So now the 3D model should be spinning as well. Check this out. It'll make a circle around the Y axis. And finally, we have to sync the content and the texture so that these blocks appear around the model and that the video that's being played on the screen also changes. So let's do that next. I'll say content and texture sync. I'll open up the timeline and run the .call function, which allows us to call an additional function, in this case, set texture function, and we will set texture to /videos /feature-1.mp4, and we will animate the box at the same time, box1, to opacity of 1, so it's actually visible, Y of 0 with a delay of 1. Now I'll go full screen so we can very soon see those boxes that appear. But for now, I will actually duplicate these two call and to functions a couple of times for all the different text boxes that we have. 1, 2, 3, 4. That way we have the box 1, we have box 2, box 3, and 5, because we're starting from the first one. For the features 2, 3, 4, and 5. 5 different features. For all of them, we'll change the opacity to 1, the Y position to 0, and I'll remove the delays from all of them besides the first one because they'll be appearing one after another. We can also change the box names to box 2, 3, 4, and 5. Now, if you save this, you'll see this one that says summarize and draft replies to emails instantly so you stay on top of your inbox. Then as you scroll, the new video will load up and it'll say generate images and edit them with ease. As you continue scrolling, you'll see another one that says turn log articles and reports or notes into clear bite-sized summaries, and so on. And you can notice that sometimes we have that suspense showing up, which shows us the loading animation. Even though we preloaded the videos, it still takes some time to update the textures. I know it's not pretty, and the only way I was able to go around it is when I used images. So if you want to just display an image of what that feature does, we would be able to completely eliminate the loading. But since we're using the images, the loading has to be there, but it's only for this first scroll. If you continue scrolling up and down, it'll be gone. And now, alongside just displaying the text, such as generate your images, we can also add some additional information. So besides just saying feature text, let's edit this JSX a bit more by rendering an image with a source of feature.icon and an alt tag of feature.highlight. Below the image, we can render a p tag that'll start with a span element with a class name of text-white, and it'll render the feature.highlight. And finally, below the span, we'll render the feature.text. So now we have this nice looking text that has the image, so we can very easily at a glance see what that feature is all about. And if you bring this to a tablet view, you'll notice that everything still looks great, the laptop is big, and you can still see the features. Sometimes it goes over them, which also I believe adds that special touch to this 3D element. And that means that the feature section is done. So let's go ahead and commit it by running git add dot git commit -m implement features section, and then git push. Just 2 more sections to go, and the next one on our list is the highlights section. So let's implement that one next. Let's implement this next section, which seems just like a vertical list of cards on mobile, but if you expand it a bit, you'll quickly see that it turns into a bento box layout. Yep, right here on desktop, there's never been a better time to upgrade. So let's go ahead and implement it. Right here under highlights, I'll turn this into a section with an ID equal to highlights. Then within it, I'll render an h2. And now we want to copy the text over from a finished website. There's never been a better time to upgrade. Feel free to copy it or just type it yourself. And then below that, we'll have an h3 that says, here's what you get with the new MacBook Pro. So now if you head back over to your current application, and if you scroll down, you can see this title. Below that, we want to display these 4 different cards. So let's create a new div with a class name equal to masonry. This layout is also called a masonry layout. If you Google it, you'll see something that looks like this. You could also consider it a Pinterest layout, because I believe they were the first ones to popularize it. So within this layout, you can create another div with a class name equal to left column. And then within the left column, you can create another div that'll have an image of source /laptop.png with an alt tag of laptop. And below it, you can have a p tag that'll say fly through demanding tasks up to 9.8 times faster. And now on the current website, you cannot see it yet. That's because this left column has an opacity of 0 applied to it at the start. If we remove it, you'll be able to see it here. But we're keeping it 0 at the start so that we can then animate it in later on. Now, on the left side, there's this a stunning liquid HDR display as well. So let's display it by duplicating this div just below and displaying a sun.png image with an alt tag of sun. And for the p tag, we'll just say something like a stunning with a break tag, liquid HDR with a break tag, and then display. That'll replicate this. Now we can focus on the right side. I'll simply duplicate this left side below and rename it to right column, within which I'll have a class name equal to Apple Gradient. For this one, we really want to make it pop with this border. The image within it will have an AI.png path, and the alt tag will be AI. And it can say something like built for Apple Intelligence. Within the p tag, we'll add a bit of a break. And then this part right here can be put into a span element. So we apply a gradient to it. And finally, for the last section, we'll have a div within which there's going to be a battery.png image with the alt tag of battery. And it'll say up to 14 hours more battery life or up to 24 hours in total. Specifically, we can put 14 hours more within a span element like this. And then that span will have a class name equal to green gradient. And then we can put a space before it and after it as well to divide it from the other textual elements. And then for this one, we can make it a bit grayish. So up to 24 hours will be within another span element. This one will have a class name of text-dark 100. And we also want to apply a space right before it. Perfect. Now, we cannot see those sections just yet because they're hidden, starting with the opacity of 0. So if you head over to the left and the right column and remove the opacity, you'll of course be able to see those sections. But we want to animate them from not being visible at all to being fully visible. So let's do just that right here above, where first we'll figure out whether we're on the phone or on desktop, because depending on that, we'll have different animations. So is mobile, use media query, you already know the deal, where the query will be a max width of 1024 pixels. And right below it, we'll open up the use GSAP hook, which will run only once at the start, within which we want to use the GSAP library. So you have to import GSAP from GSAP, and then you'll say gsap.to. We don't have to have from because we already set the opacity to 0, so we're just animating to, specifically targeting the left column and the right column, and we'll apply it based on the scroll trigger. The trigger of the scroll trigger will be the highlights section itself, and we'll start, depending on whether we're on mobile or on desktop, from bottom or from top center. I found those values to work the best when animating this section on desktop and mobile screens. We'll also, outside of the scroll trigger, apply some additional properties, such as Y to 0, opacity to 1, stagger of a 0.5, so we stagger each card by 0.5 seconds, and duration to 1, as well as the ease of power1 dot in out. So now if you reload the page and scroll down, you'll notice that they slowly appear. If you want to prolong the animation, maybe we can make this top. That way it'll start as soon as the top of the component reaches the top of the viewport. So if you scroll fast, you'll be able to see these cards animating. And on mobile, it looks great as well. Before we head over to the last component of this application, yep, we're there already, and that is the footer. Let's not forget to commit the changes right here by running git add dot git commit -m implement highlights section and git push. With that in mind, we can get started with the footer. Our footer will be super simple, as is the footer of all professional websites out there. Sure, you can make the websites pop with 3D models, videos, and make people really want to buy your products. But top navigation and bottom nav is for giving them the links to actually buy it. So every single important link that has to be there, but we didn't include it throughout the landing page itself, well, now we can show it here. So let's replicate this very simple footer on our own. Of course, it looks good on tablet and desktop devices as well. So as CodeRabbit earlier suggested, let's use an HTML5 semantic footer tag, and within it have a div with a class name of info. This is for this line right here and the logo. So I'll immediately create a new p tag and duplicate this piece of text within it. Of course, you can actually turn this into clickable links or anchor tags. And then below it, I'll render an image. This one will be a source of /logo.svg with an alt tag of Apple logo. And then we want to go below the div, create one horizontal rule, which is this line right here. Below it, display another div with a class name of links, and then render a p tag, within which we will display the copyright. And then below that p tag, we'll render a UL, an unordered list, through which we will map over the footer links. And then for each one of these links, we will automatically return an li with a key equal to link.label, or we can just destructure the label and the link from the link itself. So now we just have to say label. Within it, we will also render an anchor tag that'll have an href of link, and it'll display the label for each one of these links. If you've done that, your footer should now look like this. And we can also check it out on desktop. If you hover over those links, they'll appear clickable. For now, they don't really lead anywhere, but rather bring us back to the hero section. So now that we're officially done with all of these sections of our application, just before we commit it and open up a final PR, let's run it through the CodeRabbit CLI one more time and press enter to review all the latest changes. Let's channel the spirit of senior developers. Look at that, not too many issues, just in the performance.jsx file, where we need to improve the accessibility with some meaningful alt text. Yep, performance image 1, 2, 3, and so on, which you can either auto-apply, or let's not be too lazy, let's head over into the performance file and immediately just apply a nice alt tag right here by saying performance image number, and then we can render the actual index of that +1. So it's going to be performance 1, 2, 3, and so on. And we can turn this into a template string. 1 is fixed. And finally, we have to remove the duplicate wrapper element. Oh, is that really the case? It appears it is. Okay, this was actually a super nice catch. Also in performance, on line 7172, we have a duplicate wrapper. We definitely want to remove this one right here. And with that in mind, we have resolved all of those issues, and we are ready to push the changes over to GitHub by running git add dot, git commit -m, implement footer, and git push. That'll allow us to open up a new PR and know for a fact whether we are indeed ready to merge it into the main branch. Before we merge it, CodeRabbit has to take a look and let me know that it's okay with merging all of those changes. So I'll go grab a cup of coffee, see what feedback it comes with, and let's fix it so we can be 100% certain that we're finalizing this app with a clean and error-free codebase. And here we are with a full walkthrough of the added features. I mean, just for a second, imagine that you didn't write this code on your own, but rather that a colleague or another developer in your team wrote the code. Seeing this is super useful because it explains exactly what happened. This PR will add 4 UI sections: performance, features, highlights, and the footer into the app composition. We're implementing the GSAP-driven scroll animations and React 3 Fiber 3D model interactions, including the store-managed video texture and color application to a MacBook model. This is exactly what we've done. And we get an even more detailed diagram. This one explains how the model spins as we scroll the page, and here we can see a bit more about the performance implications. This time, the comments include minor issues, such as adding a key prop to a mapped feature. Oh, look at that, I really did forget to add a key to a mapped element, which can often cause some inconsistencies. So a very simple thing is to just add it right here. Last time I showed you how we can immediately commit this suggestion so that it now includes a key, but as you can see, you'll have to carefully review this before committing, because sometimes, like in this case, it's adding more stuff than it's taking away. It's starting to add an additional div, but it's not removing one at the top. And then it's ending without a div, but here it has a new one. So instead of doing this manually, the other thing that it gives you is the prompt for an AI agent. Nowadays, almost every single IDE has AI features built in. So just copy the prompt, go back within your application. In this case, I'll open up Junie, and I'll simply paste what I copied over from CodeRabbit. And in a second, a key attribute was added to the mapped element without us having to touch a piece of code. Perfect. And besides the nitpicky comments, that's it for this review. So before I merge, let me quickly commit the change by running git add dot, git commit -m, add a key when mapping over the elements, and git push. With those changes implemented, we are now ready to merge this PR. And the last thing we have to do is deploy this app to the internet so that everyone can open it up. We can do that right here within the terminal by running npm run build. This will create the optimized production build of the application. Once you have it, head back over to your hostinger's dashboard and open up the dashboard for this specific application. Then open up the file manager, head over into public HTML, delete the default PHP, and instead, you can right-click on the dist folder that was created for you when we ran npm run build, and you can open it up within Finder or File Explorer if you're in Windows. Once you have it, you can head over into it, and then drag and drop all the files to this public HTML. It'll take some time because we have some larger files over there, but as soon as it is done, you can head back over to your dashboard and just click on your domain name. Immediately, your application will open up, but this time not on localhost, but rather on a real online domain name that is HTTPS secured. As you open it up, we first have this MacBook opening up section. Then we have this 3D model that you can move around and change its colors and sizes. Moving down, we have this beautiful full page video section that then transitions over into a mask element showing the M4 chip that is powering the MacBook that you're about to buy. Then we can see what that MacBook is capable of by displaying all of these different apps. And finally, we can see it in a new light by seeing the exact types of apps that it can run, most of them being AI powered. And of course, there's never been a better time to upgrade, which is our last section, and finally the footer. This was such an amazing build, and I'm super happy that you came all the way to the end of this course, because now you've not only built, but also deployed this amazing GSAP and Three.js powered application. If you like this course, head over to jsmastery.com and take a look at the Web Animations full course, where you'll learn how to come up with animations on your own. We'll start from the beginning by getting started, targeting the elements and understanding properties, all the way to different easings, which shows you how the animation actually plays out in real time using animated graphics. And you can see that on the elements moving around. Not only that, at the end, you will build and deploy a GTA 6 animated website with all the sections that the real website has. And finally, we'll dive into the emotional design case studies, where you can see how Apple, Duolingo, Stripe, Revolut, and other huge companies are using animations to their advantage. Once again, congrats on coming to the end of this course, and I'll see you on the inside.